All right, project. Let's go over the rubric first, and I'll kind of explain this. So the goal of this project is basically you're going to do a PHET simulation and kind of create a lab based off of that. They're really good simulations that you can get through, I think, Colorado University, and because of it, I always used a lot of them. And when I taught high school, maybe I did in-person labs, but I also had these as kind of supplemental. Also, it's really nice when you have a sub, you can leave these and it's pretty easy to do, so you can kind of at least get some sort of lab experience without actually being there. Because some people will leave subs to do labs, but I won't do it because I'm just afraid of getting sued, or at least I was afraid of getting sued. I guess I still am. So a key to this is you need 8 good questions, basically a higher level thinking questions, like an analysis question, like on the Bloom's scale. Um, it doesn't have to be physics. You can do anything out of the entire choices that you have there. Um, and a secondary goal is a lot of you are in your pre-student teaching, and sometimes I've had you guys have used it for your within your pre-student teaching, so you kind of kill two birds with one stone. But okay, so your project, it's not only worth 5% of your grade, so it's not huge. It doesn't really take a lot of time, so that's why it's only 5%. But basically, you need 8 good questions. So basically, I need to see 8 questions that are kind of analysis that explains things, and I'll give you an example here in a moment. Then 5 points for clarity, 2 for spelling mechanics and formatting and presentation. A lot of the formatting and presentations is so unless you specify otherwise, I'm assuming, like here's my example, that the student's going to actually write on this paper. So you need to leave room for the students to write on the paper, and that's kind of what I'm talking about formatting. Like if it's really wonky and hard to follow, then you might lose points there. So make sure that it has a good format so that you're gonna otherwise you're gonna get a lot of questions if you don't have a good format. For example, my wonderful lab when I totally screwed up all those numbers. Yeah, that happens, and it takes multiple years of doing something before you actually get it right and everything's 100%. So, so what are the simulations? So let's see here. Where did I put it? Okay. This is one of the simulations. It's called Energy Skate Park, and it didn't let me go. There we go. All right, so if you see him, he's going up and down and up and down and up and down. That's what I have them use, and then I'll ask some questions about that. So I have them click on a bar graph and say, what's the relationship between kinetic and potential energy? Well, whoopsie, struggling here, going back. Well, I can see here when kinetic goes up, potential goes down, and when potential goes up, kinetic goes down. So they're an inverse relationship. Or a negative relationship. There's different ways you can express that. That would be what I call a good question because it actually makes them think a little bit. A not good question would be, what's the value of the total energy? Now, I don't have a way of finding it right here, but you kind of get the picture. And then I ask them, follow-up questions. What do you notice by the relationship between kinetic and potential energy? What do you notice about the graph of thermal and total energy? That one probably wouldn't be so much of a good question, the thermal energy, but it is important to note that the thermal energy stays constant, as does the total energy. And that's because it's the conservation of energy. It's a combination of thermal, potential, and kinetic to create your total energy. So this kind of, there's all sorts of things you can do with it. Like they have Playground here where you can literally build pieces and I don't know, have fun with it. And then I can take him and then and he just goes zoom, 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 and then flies away. And you could also change the value of friction and mass, but that's my example, and I think I have that up there on what I'm talking about with good questions. There are tons and tons of different options for the PHE simulations. If I go back here, it doesn't have to say have to be physics. So if you're going to teach biology, you can do a biology one. There's not as many with biology. There are a lot more physics. But you can see here, if I uncheck physics, you probably just want to stick to the HTML5 because Flash is dead on most of your computers, and I've noticed that a few of you have, or at least one of you has a Mac, and Macs do not will not let you do Flash, like no matter what. But yeah, so like for chemistry, you got acids and bases solutions. There's one for biology. It's more ecology. But if you dig through it, there are tons of different ones, and some of them are really fun. There's a math one for graphing. This one really doesn't make a lot of sense, but it's kind of funny. Johnter voltage. But yeah, different ones you can do. You can choose whatever you want. One of the things I tell my students is if you want, you can email to me ahead of time before the due date, and I'll look it over and tell you at least some of the things you need to fix. Like, if you don't have enough decent questions where you miss most of the points, I will tell you that. So I highly recommend that you kind of send me it as a rough draft so I can look over it and send it back to you. And once I do that, you can make the changes. So generally, this is a pretty easy A if you just send it to me ahead of time, and I'll tell you what kind of corrections to make. So do that. But I've posted this stuff under projects, so if you have any questions, let me know. I will post this video here soon, which I guess really doesn't matter because this isn't real time, because this is now in the past once you see it, but you kind of get the picture. If you have any questions, let me know. That's it.